Hello everyone, we are discussing LCR circuit and so far we have developed these things. EMF of the source is E naught sine omega t. Current I is flowing in these three components L, C and R, and again this arrow, it simply will change the direction as time changes. And what we developed in the previous lecture was these things, that I is I naught sine omega t plus phi, where I naught is E naught divided by Z I naught, which is the peak value of alternating current, is E naught by Z. This Z is called impedance. And simply remember impedance as what? Resistance offered by LCR circuit. Ampere, volt, ohms. So this Z, its unit is what? Ohms. It is impedance, which is nothing but resistance offered by the LCR circuit. And its value was root over R square plus XC minus XL whole square. This is the value of Z. And this phi tan of phi is XC minus XL divided by R. These are the things which you need to remember as far as LCR circuit is concerned. In books and maybe in your school notes, you may find XL minus XC. Just don't worry, maybe they are using minus phi over here. If somebody uses omega t minus phi at this place, then for them tan phi will be XL minus XC. As far as this is concerned, there is nothing which you have to worry. If you keep XC minus XL or you keep XL minus XC, they both are what? Same, because of the square term. This is something which you need to learn. The things which we did in previous lectures means where we developed this whole thing, or we developed the concept of pure resistor, pure capacitor, pure inductor. Everything in those parts can be understood with the help of this much information which is present on the board. What I am saying is this: if somebody gives us pure resistor, pure resistor means this. For pure resistor, Xc, XL, they are not present, and therefore it is what? 0. Pure resistor. Xc is not present, XL is not present, take it 0. If Xc is not present, XL is not present, then what is tan phi coming? For pure resistor, your tan phi is coming 0. Which means what? Which means phi is what? 0. What is phi? Phi is phase difference between the current and source EMF. This is omega t, this is omega t plus phi. That means if you have a pure resistor, then this EMF and the current flowing in the resistor, there is no phase difference in those things, which I hope you remember was a statement for pure resistor also. Similarly, if somebody goes for pure capacitor, R, XL, these values are 0. R is not present, L is not present, only C is there, that is called pure capacitor. In this case, your tan phi, it becomes what? Only Xc is present, XL is not there, R is not there, which means this is Xc minus 0 divided by 0. So what is tan phi then? Tan phi is coming infinite. And when tan phi is infinite, what's the value of phi? Pi by 2. So I hope you remember, for pure capacitor, if somebody has a pure capacitor connected with an alternating source like this, then the current and source EMF. Source EMF, you know, in that case is the potential difference across the plates of the capacitor. Phase difference between these two was 90 degrees. So if your tan phi is coming infinity, it means it is giving you the value of phi as what? 90 degrees. And for the last part, you can understand that directly. If somebody has pure inductor, only L, that means C and R, these are not present. If C is not present, R is not present, this is 0, this is 0, tan phi is what? Minus of XL divided by 0. In that case, your tan phi will look like this for pure inductor. 0 minus XL divided by 0. What is this? This is coming minus of infinity. If tan phi is coming minus of infinity, then you know that for this, phi is what? Minus of pi by 2. That means everything which we have done previously can be developed with the help of this and this. If you have pure resistor, these are not present. Z is R. What is that? Resistance offered by the circuit, which is coming R. If you have only capacitor, this is not there, L is not there, only Xc is present, Xc square under the root is what? Xc. And that was the case with pure capacitor. So, For any combination of L, C, R, from now onwards, I expect that you will remember this and this. And as I told you, if this is plus phi, tan phi will be xc minus xl divided by r. You can simply remember this way. The first thing which you were taught in 12th was capacitance. So first comes what? Capacitance. And then when we started magnetic field and all, you were taught what? About inductors. C comes first and then comes what? L. And R is in the denominator. Note down this much. And then we'll take some examples. You should note down every part systematically. Pure resistor, show this, draw the figure, write down like this, tan phi is coming 0, phi is coming 0, and these are not present, Z will be what? R. And same thing for practice you can do with what? Pure capacitor and for pure inductor. You must note down things in a systematic way. Now tell me if we have a circuit where only C and L, capacitor and inductor, are present. Note down this question. Look here. We have an inductor and we have a capacitor. They are connected to an alternating source. XL is 20, XC is 10. E is 5 sine 2t. This is the EMF, 5 sine 2t. XL and XC. Find out I as a function of time. You need to write I as a function of time in the comment box. Should not take more than 1 minute. Let's see how fast you are. Find out current in the circuit as a function of time. I've got 2 answers so far. And these answers are not correct. Out of 4, only 1 answer is correct. And well, it's very strange. Things are on the board and you cannot even put values in these formulas. So if I ask you what is phi, you will use this formula. What does it say? Tan phi is xc, tan minus xl divided by r, which is not present. What is tan phi? Tan phi is coming minus tan upon 0. What is minus tan upon 0? Minus infinity. Tan phi is coming minus infinity, that means phi is coming what? Minus of pi by 2. You're supposed to get phi and then use this formula. What is r? It's not present. Xe is 10, xl is 20, whole square. What is 10 minus 20? Minus 10. Square, 100, root 10. So this is coming what? 10. And then you need to put these values in this. What is I naught? E naught. What is E naught? This part. E naught sine omega t. So your E naught is 5. Z we have calculated is what? 10. So your I naught is coming 1 by 2. Put it over here. I naught is coming 1 by 2. Sine omega is what? 2t. Omega t plus phi. But what is phi? Minus pi by 2. This is your I. If this is your I, this is what? Theta minus 90 type of thing. And for that, you do what? You will take the negative sign out. Then it becomes this sine of pi by 2 minus 2t. Take the negative sign out. This becomes pi by 2 minus 2t. What is this? Sine of 90 minus theta. That is what is cos theta. Your I becomes minus of cos 2t divided by 2. That's the answer. Everything is on the board, but still only one person could get the answer in time. Well, this is the easiest question which you can expect in alternating current. Let me tell you this. Now let's see how much you know. Get me the value of VL. Find out in the same question VL. Whenever I say VL, that means instantaneous value of potential difference across the inductor. Instantaneous means as a function of time. Find out VL as well as VC. Get these values. Everything is on the board which you need. If you wish, you can see your notes from the previous class. Although I gave you briefings from those lectures in the very beginning, but still if you need, you can go through that part. Find out VL and VC. Should not take more than 1 minute. Let's see how much time you take. So if I need VL, then what was VL? VL, it had a peak value VL naught. How did we obtain VL naught? VL naught was I naught multiplied by XL. We have the value of I naught. What is I naught? 1 by 2. This is I equals to I naught sine. So 1 by 2, the magnitude, mod part, is your I naught. Multiplied by XL, which is 20. This is coming 10. We got the value of VL naught. What is VL? VL is sine of, I hope you remember this from LCR. If I is this I naught sine omega t plus phi, then VL naught is what? Sine of omega t plus phi. For an inductor, current is something which lags behind current. So if current is known, then potential difference is going to lead. Lead means you will be using plus of pi by 2. VL naught sine, this is the phase of current. And for a pure inductor, look here, pure inductor means Xc is not there, R is not there. So this is giving you what? Phi as minus pi by 2. But remember, what is this phi? This phi is the phase difference of current. That means current is behind. When you get minus pi by 2 over here, it tells you that current is behind. Since current is known, potential difference is going to lead. Remember this way, plus pi by 2. And now let's save time. What's the value of phi? Minus pi by 2. This is what? Pi by 2. Pi by 2 minus pi by 2 gone. VL naught is coming what? 10 sine omega is what? 2t. This is your VL. Phi for this circuit was minus of pi by 2. Put it over here and you get your VL. Now, those of you who could not answer even this, go for VC. I'm giving you another 1 minute. Use the same technique and find the value of VC. And for the sake of God, at least produce the value of VC. There are few who are simply sitting in the class, no responses coming from them, even for these simple things. I mean, you should be ashamed of yourself. You're not even answering a single thing. I've been telling you again and again, give me something. When you write something wrong, then I get to know that what you are thinking. And then I can modify the way you solve these questions. If you answer nothing, I get no idea. I just don't understand what is your understanding level of a particular chapter. So remove this fear of writing wrong values. Produce something, anything, whatever you understand. Well, those of you who are writing the masses as minus pi and all, simplify it and then produce the answer. For capacitor, VC is VC naught peak value sine of omega t plus phi. This is the phase of current. Phase of current is omega t plus phi. For a capacitor, current leads the potential difference across the plates. So if current leads, that means if current is given, current is known, then potential difference will be behind. Behind means minus of pi by 2. This is the phase of current. And potential difference lags behind. Phi is what? Minus of pi by 2. So when I put this value in here, what is VC naught? I naught. What is I naught? 1 by 2 into XC, which is 10. Remember, you will not take I naught as minus half. I naught is the mod of peak current, which is 1 by 2. It's 1 by 2 into 10 sine 2t minus pi by 2 minus pi by 2. This becomes 5 sine 2t minus pi, which is minus of 5 sine pi minus 2t. Take the negative sign out. Once I take the negative sign out, it becomes pi minus 2t. What is sine 180 minus theta? Sine 180 minus theta is sine theta. So this is minus of 5 sine 2t. That's the value of VC. Minus 5 sine 2t. That's the value of VL, 10 sine 2t. Note down this. Take a homework for this question. Plot a graph of E versus T, I versus T, VL versus T, and VC versus T. You can expect these type of things in any examination. You will be given 4 options and you will need to identify the correct one. So take this homework and try to send this once you solve it. For all the instantaneous values we developed, you need to plot their graphs. Note down this question. Write down the question. Potential difference across the inductor. Potential difference across the inductor is 100 volts. Potential difference across the capacitor is 60 volts, and potential difference across the resistor is 30 volts. First tell me, when I give you potential difference across the inductor as 100, for capacitor 60, for resistor 30, what are these values? Just taking an idea from you if somebody knows it. I have not told you this, and therefore if you don't answer this thing, there is no issue. But let me see what is your thinking level. These are instantaneous values, these are average values, or are these the RMS values? What do you think? When I give you 100, 60, 30, then what type of values are these? One of you is asking to repeat the homework. Homework was in the previous question for all the values E versus T, I versus T, VL versus T, VC versus T, you need to produce the graphs. For all the instantaneous values, E versus T, VL, VC, all those things. Good. The answer is correct. These are RMS values. It cannot be the peak value. It cannot be the instantaneous value first. Why? Instantaneous value has what? Sine omega t plus type of format. You have been given a single value. This cannot be the average value. For average, you know, average of VL, it will be what? 0. Normally average is asked for one complete cycle, and you know that for one complete cycle things are positive for half of the time and negative for half of the time, and therefore average is also what? 0. These could have been the peak values, but we do not provide peak. Convention is that whenever question gives you, these are the RMS values. So in a question, if they have given us something like this and nothing is mentioned, then remember these are root mean square values. Those of you who have seen the RMS lecture where I taught you how to find RMS values. If you have seen that lecture, then write down yours in the comment box. And now note down the question. We'll handle the whole thing step by step. You got L, you got C, you got R. First thing, find out ERMS, that is RMS value of the source EMF. This is the first task. Find out RMS value of the source EMF. I got a single response, and the response is not correct. Instantaneous value of source EMF is E. Instantaneous value of potential difference for the inductor is VL, for capacitor VC, for resistor VR. Peak value for VL is VL naught. Peak value for VC is VC naught. Peak value for VR is VR naught. Peak value of source is E naught. RMS value for VL is VL RMS. For VC it's VC RMS. For VR, for resistor it is VR RMS. Instantaneous peak RMS. Instantaneous peak RMS. And for your source we have ERMS. I hope you remember this from LCR circuit, that VL plus VC plus VR, this was equal to E. This is coming from Kirchhoff. If you run a closed loop, then this plus this will be equal to what? E. VL naught plus VC naught plus VR naught equals to E naught. Is this relation correct? Yes or no? Between the instantaneous values, we can write this. But can we say that we can directly add peak values and we'll get the peak of source? Is this statement correct? What do you think? Yes or no? Write down in the comment box. Write down this in the comment box. Good. This relation is not correct. Is there anyone who can tell me why this relation is not correct? If you think you can answer this, you can switch on your mic or you can write in the comment box. What makes you think that this relation is not correct? It's not correct, that is true. But what is the reason? What can be the reason behind this? If this is true, Then what is wrong with this? VL naught, VC naught, VR naught. You can answer this with a single word. Good. Last two answers are correct because there is a phase difference between VL naught, VC naught, VR naught, these peak values. Instantaneous means what? Instantaneous means at a given time you found that VL, let's say 10, suppose VC minus 5, VR plus 30, something like this. So if somebody observed these instantaneous values, if you add all the instantaneous, it will give you what? E. What do you mean by instantaneous? Instantaneous means all those values, they take place at the same time. If somebody finds 10 volts over here, that very moment he observes minus 5. And that very moment he observes whatever the reading was for VR. These are called instantaneous. You will add them and you will get what? E. We'll write the whole statement also. Peak values. Peak values means what? Its peak will come at certain time if this VL naught takes place at a given time. Then at that very time, peak of VR will not take place because they have a certain phase difference. A certain phase difference means they all have same current, but with respect to current, their potential differences are in different phases. So their maximum values, they occur at different times. These peaks, they do not take place at the same time. They occur at different times and therefore you cannot directly add them. I'll try to help you this way if you can understand this. Just for the time being, to keep everything easy, suppose this is the graph of I. Not for this question, I'm just giving you an idea. So I've taken I as a function of sine theta. Then, how do you draw the graph of VR? Graph of VR will be plotted like this. This will give you the visualization why all these values, they do not occur at the same time. Look here. This is the graph of I versus T. I versus T. If this is I versus T, then VR versus T will be exactly same. You know why? Because I and VR, they are always in same phase. Remember, I am not plotting values for this particular question. I have taken a very easy setup where I is a simple curve so that we can easily plot VR and all. This is VR. How do you plot VC? This is I, this is VR. I'm asking you to plot VC. Do it fast, plot VC, and once I draw it and you get the same thing, then you will write yes in the comment box. 20 seconds. So this is I, and you know that for a capacitor, current is something which leads. So current is leading. What is current? Current is some sine omega t. We are interested in phase part, we are not interested in the peak values. So forget about the peak value. I'm teaching you how to draw these curves fast. So somebody has given us curve of I. If we have I, then VR, it will be some peak value and then sine omega t. I'm not interested in the peak value and therefore I'm not using those. But if I ask you what is VC, some peak value and then sine of omega t. If you have what? Current, then current leads potential difference for a capacitor. That means potential difference is what? Minus of pi by 2, which is what we have been doing again and again. Let me write it fast. Minus of cos omega t. So VC is what? Minus of cos omega t. What is minus of cos omega t? This is minus of cos omega t. So those of you who have plotted this graph, write down yes in the comment box. For VC, if you have done this, then write down yes in the comment box. Good. What about VL? Let's be fast. If VC is minus cos omega t, VL will be what? Plus. Let me write over here. VL, it will be what? Some peak value sine of omega t. This is the phase of current. In inductor, potential difference. In inductor, current lags behind. You remember that. Current lags behind means potential difference leads. Potential difference leads plus pi by 2. What is sine of 90 plus theta? Cos. And how do you plot a graph of cos? Graph of cos is plotted this way. It's a very important graph for you. If we have I, now let's talk about the peak value part. This is the peak of VR. This peak of VR in this graph takes place at t by 4, capital T by 4. This is capital T, one complete cycle. When time is t by 4, we found that VR is maximum. But right at this moment, look at this VC. It's what? 0. Look at VL, 0. So these peak values, they do not occur at the same time. Again, when time is t by 2, when time is t by 2, look at these values. VR is 0. VC is maximum on the positive side. VL is maximum but on the negative side. So somebody who gave us peak values, if he adds all these, then we have a problem. These values cannot be added. Sorry, instantaneous wise you can always add, but the argument is peak values, they do not take place at the same time. When VC is maximum, VR is not. VL is, but on the opposite side, that's negative value. That's the reason you do not add peak values for finding peak value of the source EMF. Write down fast this statement. By the way, do you understand this logic? Yes or no? Write down fast. Are you comfortable with the logic? Good. Write down the statement. Since instantaneous values in equation number 1, call it equation number 1. Since instantaneous values in equation number 1 all take place at the same time, we can add them using Kirchhoff's second law. But this cannot be done in equation number 2. Call it equation number 2. Equation number 2. But in equation number 2, all the peak values, they occur at different times, and therefore cannot be added directly. And same goes with RMS values. You cannot add them directly. Same goes with RMS values. You cannot add them directly. Well, the reason is quite simple. These are the peak values, and you know that your RMS value, VL RMS, it will be what? VL naught root 2. So there is a direct relation between RMS and peak. So whatever happens with peak, multiply that with root 2 and you will get what? RMS values. For VC, you will be writing VC naught. VR, you will be writing VR naught into root 2. Then, how do you obtain the correct part? Now look at this. We have developed this part, I naught, as E naught divided by Z, which is E naught divided by root over R square plus XE minus XL whole square. This is your I naught. E naught divided by root over r square plus xc minus xl square. Now let's be fast. This thing is nothing but this I naught square r square plus I naught into xc I naught into xc minus I naught into xl whole square E naught square. Simple maths. Move this term over here, square on both sides, and you get this. I naught square, root is gone, r square. Take I naught inside, and you get this. Simple maths. Now what is I naught into r? VR naught. What is I naught into xc? VC naught. What is I naught into xl? VL naught. So what is the correct answer? Correct answer therefore is this. For peak values, the correct thing is V R naught square plus VC naught minus VL naught whole square is equal to what? E naught square. This relation is the correct one for peak values. And similarly, if you multiply every part VR, if you multiply this term with root 2, this term with root 2, this term with root 2, and this term with root 2. I'm skipping that part because it's very simple. If you multiply every term with the same number, then the relation will be same. But once I multiply this thing with root 2, VR with root 2, it will give me what? RMS value. So the same type of relation is also for RMS values, which is this V R RMS square plus V C RMS minus V L RMS whole square equals to E RMS square. Fourth relation, which is also correct. Now, they're not different type of things. They all are coming from what? This I naught equals to E naught by Z. You're simply squaring this part. Once you square this, you arrive over here. So this is same as this, and then you multiply root 2, you arrive at this. There are only two types of things you need to remember. This is the instantaneous. This, which is the peak value relation and RMS value relation. Last 1 minute, and the question was, we had been given RMS values in the question. These are the RMS values. So if somebody says find out E naught, and you do what? You add all these 100 plus 60 plus 30, you write 190, then it will be wrong because you are doing this, which is not correct. You are basically adding the RMS values directly. This is not correct. The question was looking for RMS. For RMS, if you add all these, that is not correct. So how do you find RMS? For RMS, you have to use this relation, which is what? E RMS square is what? VR RMS 30 square. plus VC minus VL. VC minus VL. 60 minus 100. You're not squaring 60 and 100. You're squaring what? 60 minus 100, this part. You're squaring what? VC minus VL. This gives you ERMS as what? Root over 30 square plus 60 minus 100, 40. This is coming 40 square, which I suppose you know gives you what? 50 volts. That's the correct answer. ERMS is coming 50. It's not coming 190. If you understand this, then write down yours in the comment box and then you can leave. Thank you very much.